Okay, so we're going to start a new unit on sequences. And sequences hopefully won't be too hard. I think they're pretty easy. So we're just going to start looking at real basic stuff, and then we'll get on into some harder things later. But this first lesson should be pretty easy. So many times patterns arise in math. You can describe patterns, a lot of patterns, with sequences of numbers. And so a sequence is just a list of numbers that follow a pattern. Alright, so each number in a sequence is a term. And so terms, whenever we are representing these in this unit, we're going to use this notation, A1. And A1 would represent the first term in a sequence. That's term. A32 would represent the 32nd term. A50 would represent the 50th term. So whatever this little subscript is, that's going to be whatever number the term is. Alright, so we're just going to look at this first sequence that is generated by this lovely picture. So in our first term, or our first picture, we have one side. And so then each time I get a new term, I'm replacing this line with this picture. So I replace this line with this picture, that gives me 4 sides. If I replace each one of these lines with this picture, then I would get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16. So I would get 16. So hopefully at this point you can see a pattern. And so then if I were to replace all 16 of those sides with that, all I'm doing each time is multiplying by 4. So 1 times 4 gave me 4, 4 times 4 gives me 16, so 16 times 4 would give me 64. And so each of these, this is A1, A2, A3, A4. So each of those are terms in our sequence that we generated by this picture. Alright, so what was the pattern? We were multiplying, I'm just going to say multiplying by 4. What would the next term be? So I would say 64 times 4. And if I did that, I would get 256. Alright, so in these problems, in these first few, we're just finding a pattern. And it's just that simple. So when we find this pattern, 27, what would I do to get to 27, or from 27 to 34? And then what would I do to get from 34 to 41? And so if I look at that, hopefully you can see that the pattern is going to be, I am adding 7. So I'm just adding 7 to each of these. So describe the pattern, I'm adding 7. The next 3 terms, 48 plus 7 would be 55. 55 plus 7 would be 62. 62 plus 7 would be 69. So those are our next 3 terms in the sequence. Alright, so describe this pattern. Okay, so when we're describing the pattern on this one, I want you to take just a second and see if you can figure out the pattern. This should be easy. So all I'm doing to get to the next term is dividing by 3. And then if we were to find the next 3 terms, 9 divided by 3 would be 3. 3 divided by 3 would be 1. And then I'm just going to leave the next term 1/3. Alright. Now, a lot of times we can represent sequences with a rule or with like a formula. And so I'm giving you in this one, just to get used to this notation, this formula for a rule, and I want you to generate the sequence by using this rule. So in this sequence, n is just the number of the term in the sequence. So for example, if you're finding A1, all I'm going to do is plug 1 in for n. So I'm just going to plug 1 in for n. So whatever this number is, these numbers should match. So if I'm finding A2, I should plug 2 in for n. 3 would plug 3 in for n. So for A1, I'm just going to do this in my head. 3 times 1 is 3, plus 4 would give me 7. A2, I would plug 2 in. 3 times 2 is 6, plus 4 would give me 10. A3, 3 times 3 is 9, plus 4 would give me 13. So hopefully you can see that there's going to be a pattern in this, and this is just going up by 3 each time. So the next term would be 16. Right, here's a little bit more of a complicated sequence. I'm just going to plug 1 in, and I'm going to do this, I'm going to write this out. So I'm going to plug 1 in to find the first term, so -1 to the first, 3 to the first minus 1. And so -1 to the first is just -1, 3 to the first is just 3, and 3 minus 1 would give me 2, so -1/2. The second term, I would say -1 squared, 3 squared minus 1. So -1 squared is 1, 3 squared would be 9, and 9 minus 1 would give me 8. A3, I would say -1 to the third, 3 to the third minus 1. And so then this is going to be a -1 over 3 cubed would be 27. And so 27 minus 1 would give me 26. And then my last one, -1 to the fourth over 3 to the fourth minus 1. And so -1 to the fourth would be a +1 over 3 to the fourth is going to be 81, minus 1 would be 80. And so this would be my sequence. And so you can write your sequence, I didn't do this on the last one, but you could write it as -1/2, 1/8, -1/26, and 1/80. So instead of writing A1, A2, A3, A4, you can write it like this whenever I'm asking you to do a problem like this. I just showed these because I wanted you to be able to see what I was plugging in for you. Alright, so now, there are two different ways that you are going to see formulas that represent sequences. One of those is a recursive sequence, and one of those is an explicit sequence. And so a recursive formula, or a recursive sequence, is just going to be a formula generated by previous terms. Okay, so you're going to use previous terms to generate next terms. And so I've got an example, a real life example here for you that will hopefully help you see what I'm talking about. So it says, suppose you drop a ball from the height of 10 feet. So this is my starting height. That would be my first term in this sequence. So after the ball hits the floor, it rebounds to 85% of its previous height. So how high will the ball go after its fourth bounce? And so in order to find its fourth bounce, I'm actually going to need to go, since this is where I start, the ball hasn't bounced at all. This would be after the first bounce. This would be the second, third. And so I actually need to find A5 to find the fourth bounce. So I need to go down here and find A5. Okay, so then all I'm going to do is take 85% of 10, and to do that, I'm just going to multiply 10 by 0.85. So change it to a decimal, multiply by 0.85. So it's going to rebound to 8.5 feet after the first bounce. The second bounce, I'm just going to multiply, I'm going to take this term, so the previous term, so to find A3, I would take the previous term, 8.5, and multiply it again by 85%. So that'd be 7.225 feet. To find A4, I would multiply by 0.85 again. That's going to be the third bounce. On my paper, I'm going to write 6.14, but in my calculator, I'm going to keep all those decimals. And then the fourth bounce, that'd be A5, I'm going to multiply by the 0.85 one more time, and so then that would be 0.522, or around about, so 0.522 feet. So this is how high it would rebound after its fourth bounce. And so all of these terms we got by basing like the fifth one on the fourth term. So it's based on the previous term. So now we're going to talk about, this is easy to generate numbers like that, but I'm going to talk about how to come up with sequences or formulas. So a lot of times it's useful to write a rule or a formula. And so if you had a rule to represent the last situation, you could find the height of the ball after any number of bounces. And so to write the formula, you have to define terms based on the previous term in the sequence. So we're just going to look at some notation before we write a sequence. So if we have A1, A2, A3, that's the first, second, and third term. So this is the way that you will see these represented, okay? If A2 is a random term, then the term before A2 is A1. And so what I did to 2 to get to 1 was subtract 1. So if you ever see this AN minus 1 notation, This is not telling you to subtract 1 from anything. It's not telling you to plug n minus 1 in for anything. This is just simply a notation, or like a symbol, that represents the term before this random term. So an is a random term. An minus 1 is the term before that. A3 would be the term after that, and 2 plus 1 gives me 3, so n plus 1 would be the term after the random term. And so when you see these things, that's just notation that means the term before or the term after. Most of the time, because recursive is based on a previous term, you're going to see this notation a lot in recursive formulas. You won't see this really in recursive formulas. You'll see the term before. So, if we use the random term representation, we could describe the ball's height by saying this. An, so after a random number of bounces, I'm just going to take 85% of whatever the term was before this one. And so the key is that you have to tell me where it starts. If you don't tell me where it starts, then it really is not doing any good. So if you just have this as an answer when I ask you to write a recursive sequence and you don't have this, no good. It's not right. So you have to tell what A1 is. Alright, so we're going to use this just to generate a couple of sequences, and then we'll actually write some formulas. So this, if A1, I want to write the first 4 terms. So A1, A2, A3, A4. So A1 they give to me, that is 10. So A2, all I'm going to do is take 3 times the term before, which is 10, plus 2. So 3 times 10 is 30, plus 2 is 32. For A3, I'm going to take 3 times 32 plus 2, and if I do that, that's just going to give me 98. And then for A4, I'm going to say 3 times 98 plus 2, and that would be 296. And so that's pretty simple. This one, try it on your own, then check. A1 is going to be 3, A2, A3, A4. So I'm going to plug in 3 for the term before when I'm finding A2. So 2 times 3 is 6, plus 5 will give me 11. 11 times 2 is 22, plus 5 will give me 27. 27 times 2, then plus 5 is going to give me 62. And so those would be my first 4 terms. Now, I want to write a recursive formula for this sequence. So the first thing you need to do is find the pattern. What am I going up by each time? And so this is an easy pattern. I'm just adding to each time. And so what I'm going to do is, first of all, I'm going to say what A1 is. So A1 is 2. I start at 2. Now, any term after that, I find by taking, like if I'm finding term 2, that's 4. I would take 2 and add 2 to get 4. If I'm finding 6, I would take 4 and add 2 to get 6. So I'm taking the term before and adding 2. And that's all there is to it. So this would be my recursive formula. Okay, for this one the pattern is a little bit harder to find because there's 2 things that we're doing. So think about this pattern for a second and then see if you can figure it out. You can pause it. I'm going to go ahead. This pattern is going to be, if I take 3 times 2 and then subtract 1, I get 5. 2 times 3 would give me 6, and subtract 1, I get 5. 2 times 5 would give me 10, subtract 1, I get 9. So I'm multiplying by 2 and then subtracting 1. So then I would say A1 equals 3, and AN, I'm multiplying the term before by 2 and then subtracting 1. And then that's going to be my recursive formula. Alright, last recursive formula is I'm just multiplying each of these by 3. So I would say A1 is 5, and AN is just going to be 3 times the term before. And so that's all I'm going to do. And this is my final answer. And so in the next video, I'm going to show you how to do explicit formulas, and we'll learn what those are.